Thanks for coming. And we've all been in Vegas for a while. Whoops. We've all had a few. Are we live now? We've all had a few hangovers, or I'll speak for myself. So let's make this interactive. Does anybody have any questions that they want to get started with right away? As a matter of fact, it's a small group. I'll try to get started with some content here. But if anybody has any questions, really, let's please interrupt me. We got an hour together, so I want you guys to make it useful for yourselves. So I'm the CEO of GoGrid, and what I want to talk about today is why you should care about cloud computing, not just what's in it for you, but why it's important to you, and a little bit about how you can use it and how you can get started with it. We have this thing called the cloud pyramid, and I'll show how that maps to the way Microsoft sees cloud computing and what they're doing with Azure. Talk a little bit about the competitive benefits that you can gain in cloud computing and how you get started with the cloud in a very practical, applied, easy to get going way with sort of an overview of what we think it's going to look like in the future, how GoGrid can help you specifically, and how you can plan on deploying and scaling your web applications in the cloud. So I think all of you are familiar with Microsoft really beating the drum, saying you got to get in the cloud, Azure, Azure, Azure. Don't buy hardware. We're going to be a little bit more vicious about it. So I'm going to play you this video here. This is featured at nohardware.com.
Hold on a second, you server-hugging computer geek. Why would you buy so much new hardware when you could be getting your servers in the cloud?
Well, I need something that's bulletproof.
Bulletproof?
Yeah, bulletproof. If I have any downtime, my boss will kill me.
My name's Dr. GoGrid.
Nice meeting you.
I'm writing you a prescription for uptime. It's called cloud computing. Just call me in 10 days. And I have to tell you, your servers are not bulletproof.
They're not?
That brand new hardware you just bought from Dell? Not bulletproof. Cisco? Not bulletproof. HP? Not bulletproof. Sun has shit. Servers? You don't need no stinking servers. Let them have it, boys.
All right, so enough of that. If I don't get enough questions from you, I'm going to make you all watch a couple more of those videos. And people that laugh at them get T-shirts and hats. So you're laughing, so you're going to get a T-shirt. Okay. All right, back to the slides here. The point being with nohardware.com, what we're trying to say in a fairly violent way there is the same message that Microsoft has been giving you. And that's that best practices are to be in the cloud. And if you think you need to do it on your own hardware, I think you're geeking out. Really, you need to have a mind shift. There's a new way of doing computing. And what I'm going to show you is our overview of that way of doing computing and how you can get started with it. So our definition of cloud computing, these are some of there's a lot of different definitions, but it's got to be self-service. It's something you guys have to be able to use yourself in the middle of the night. It's got to be something that, as developers, you don't need an IT staff to help you with in the sense that you did in the old days, where you develop an application and then give it off to another crew that's got to make it run right, okay? Self-service kind of goes both ways. You handle things yourself, and you've got to handle things yourself. So another neat tenet about it is that it's pay-as-you-go, and you only pay for what you need. And I'm going to come back to that because that's really some of the things driving the economics behind cloud computing, and economics is a driving force in all our decision-making right now. And then the dirty little secret of cloud computing is that it's shared. It's on a shared platform, and that's also part of the economic puzzle here that I'll get into. So why you should care about cloud computing? Because it's a 10x improvement, not in just one thing like price, but in every aspect of computing. And it touches all aspects of computing. So this just isn't better, cheaper, faster storage. This isn't just better, cheaper, faster security or load balancing or scalability. In every way, it reduces your costs, it reduces your risks, it's more reliable, it's easier to use. It's just generally an improved paradigm across the board, a tenfold improvement in every way, in every part of computing. So, as an example, you'll see billboards, AMD advertising, they've got a CPU out that's 18% more power efficient, or 18% faster for the CPU. But you still got a motherboard, you still got disks, you've still got RAM, you've still got a lot of other constraints that are part of just that compute puzzle. Okay, so just in that server node, that 18% gets diluted by all that other elements in computing. It's really not that much of a jump. What we're talking about in cloud computing is a tenfold jump in every discipline, in every aspect, every characteristic of computing. So did anybody go to James Conrad's presentation on Wednesday? You might have seen this slide. And he's talking about, this is a Microsoft slide. This is Microsoft's vision of the state of computing, okay? Where you can have your on-premises computing. These are machines that you own and operate. You have complete control, and of course you have to buy this stuff. And then hosted servers. So these are machines that you rent. You have less control, but you have fewer responsibilities, lower capital costs. It's more flexible. But you have to pay for it even if it's sitting there idle. And then what they're saying is best practices is moving towards the cloud. And that's a shared multi-tenant infrastructure. It's scalable. You only pay for what you use, and you pay as you go. Now here's how this maps to our vision. So with on-premises servers, and the reason I'm showing you this is because I want to build a case that we have a perspective on this that is expert and informed, and that can help you to make this transition into the cloud. So we have this brand called ColoServe, and ColoServe is where you buy the hardware and you co-locate it with us. And David and I have been in this business since the mid-90s, and so we're very familiar with the financial model and the challenges of co-location. And then in their continuum, they have hosted servers. And this is akin to our ServePath brand. And so David and I got this brand started in 2001 because this was better than co-location. This is where you leased your servers, and you had a lot fewer headaches. It was a lot more flexible, and the economic model was much better for you. Not just that you didn't have to buy the servers, and you translate that CapEx into OpEx, but you can actually more finely tune your purchases, because if you don't need something or your needs for it change, you can upgrade and downgrade in the managed hosting model, whereas if you buy hardware, you're stuck with it. And then 3 years ago, we started working on GoGrid. It wasn't called cloud computing then, but this is cloud services, cloud infrastructure. And we think this is best practices, and that's GoGrid, and I'm the CEO of GoGrid. So then, this is also from Mr. Conrad's presentation. This is sort of their building blocks, where you have their platform service, Windows Azure, and then you can get these application layer services on top of it. And some of you may be wondering, well, what's the relationship between GoGrid and Azure? And so what we're saying is that GoGrid is pure and simple infrastructure. It's the lowest of the layers, okay? And you've got more control with GoGrid, but as your specificity of purpose increases, as you go up the stack, you would want to use these other services. So you might even consider that it's co-location, where you may feel you have the greatest amount of control and the greatest breadth of what you can do with your hardware. ServePath managed hosting, where you relinquish perhaps some of that control, and then GoGrid, which is the broadest range of cloud computing, and then Azure, a platform service, and then some application services. So here's how we map this out. Anybody can bray like a donkey. Yee-haw! Feel free to do that. I like doing that. I'll do it again. Yee-haw! So these are the three layers: infrastructure layer, platform layer, and software layer. And so the case studies, application layer, Gmail, and Salesforce. You know, at the top of the pyramid is your specificity of purpose. At the bottom of the triangle, the pyramid, is the breadth of your purpose. So Azure, of course, is the world's greatest example now of a platform service. Google App Engine is another one. And then down in the infrastructure layer, you have GoGrid and Amazon. So just mapping that back to the Microsoft vision, they're in the platform and application layers, and we're purely in the infrastructure layers. Any questions on that? All right. So this is architecturally how these three layers shake out. I'll start from the left with the software as a service layer. You get your own copy of the application, okay, your own email environment or your own CRM environment, but everything else is in a shared environment, including the database. Okay. Going into the platform layer, Azure, for example, is going to fire you up your own database instance, and it's going to fire you up your own VMs. But if you use their storage service, that's coming off of shared storage. And of course, you have shared network capacity. At GoGrid, everything is shared across the board. So now I want to move on to our vision for how you're going to get started with the cloud and what your participation in the cloud is going to look like going forward. So right now, you've all got physical servers. I'm sure maybe some of you are. How many of you are using Amazon by chance? Huh? Not as popular with this audience as usual. How many people are using Azure already? Okay. Well, you all obviously have physical servers then, and you may be either getting them just as a show of hands. How many people own their hardware? And how many people are using a hosting company? Interesting. So we think that's a continuum, and next year at MIX, when I ask that question, I think there'll be a lot more people that are using the cloud already. And by the way, there's a free trial card for GoGrid on every chair. Take you about 5 minutes to have had some exposure to cloud computing. I'd encourage you to do that. And so you can get started as early as next week with servers on GoGrid. So I think you've seen a lot of programmatic examples of how you would use Azure, and you're thinking ahead to the day you need to rebuild an app or you need to start building an app, how you might use these tools that you've seen over the last couple days to get into Azure. But you can get started with GoGrid next week because we offer just standard vanilla architecture, and I'll get to more of that in a minute. So, you know, all of you that are owning your own servers, we think that there's a better way. And for those of you that are concerned about what about things like security, what about things like portability of my database and scalability of my database, well, we can offer you something we call Cloud Connect, where you can use GoGrid on your front end for your web servers and your app servers. And that's, of course, a shared environment. And your back end can be a dedicated physical machine that you run your database on. So we call this hybrid hosting. And we think this is a great first step for those of you that want to tinker with, get started in the cloud. You can get started with some of your web and application servers in the cloud now. And so you can start to gain a familiarity with this type of architectural principle and help work your way towards using Azure. One of the things that we're featuring is we're the only cloud that's currently offering Windows 2008. So for those of you that are looking for 2008 initiatives, you can certainly do that on our cloud. And one of the things that Microsoft is promoting is GoGrid in conjunction with Windows and PHP, and ASP.NET, Fast CGI, SQL Server. So all those things can be done. Do I have any questions about that? Hey, I'm going to, since you guys were, very few of you were using the cloud, and most of you own your own hardware, I'm going to make you watch another video.
Dr. GoGrid here, and this server hugger's got a real problem. Son, why do you like your hardware so much?
I love my hardware ever since I was a kid.
You're addicted.
I love my hardware. I'm totally addicted.
And I'm here to help. Here's a prescription to cloud computing.
Oh.
Now, son, the authorities are going to have to confiscate this contraband, and they're going to have to burn it.
Burn it? Don't burn my hardware, bro! Don't burn my hardware, bro!
Cloud computing, bro. It will help. You server huggers, you're all addicted. Get off your hardware and software. It belongs in the cloud. Burn that hardware and software. It's caused enough pain and suffering.
Okay, so I think you can see what I want you to do when you go home. You can send it to me and I'll blow it up for you. We can watch the blow up video in a little bit. But I think that these cloud mixtures are going to be what you all are going to be doing in the future. You're going to start tinkering with the cloud, and more of your activities are going to be done in the cloud. So I'd encourage you to start getting some experience now with the cloud, and that's what that cloud card is sitting on your chairs. There will be certain applications that you will start designing, that you will put on Azure, where Azure will absolutely be the most cost-effective, easiest to use, most scalable, most perfect way to deliver that application. And that's just a fact. And so I'm sure you guys have taken quite a bit of interest in Azure. But another thing that's true is that you have legacy applications and you have a breadth of needs. Maybe some of you use that L operating system for certain applications. Maybe you have certain hardware constraints where you're doing something related to telecommunications or video processing, where you need a mixture of our application, a mixture of hardware architectures. And so this hybrid architecture is something that I think you all can just plan on as part of your future. So what is GoGrid? We're the largest cloud provider of both Windows Server 2003 and 2008. We've got a web-based portal, an API, and a .NET SDK. We give you full administrator access. So these are real machines. Okay, so there's no difference between a machine you're hosting on-premise, a machine that you might be getting from a managed hosting company like ServePath or Rackspace. These are real machines, real Linux machines, real Windows machines, both. But you also get load balancing, real public and private IPs, support, all the things that you'd normally expect. So this is what our portal looks like. And I know that it's a little bit hard to see, but picture in your head a multi-tier architecture, where in the top tier you have your load balancers, then you have your web and application servers, or your web servers and then your application servers, and then in the back tiers you've got your database servers and your storage. Okay? So in this case, in the leftmost column where you see the orange, that's your load balancers. In the second column, those are your web and application servers. And in the mouse over example here, we're mousing over a Windows 2003 server with 2 gigs of RAM with the SQL Server Plus running on it. Then you have your database servers and then storage. Our storage is much like the blob storage that you might have heard about from Microsoft over the last couple days, like Amazon's S3. And then in the left-hand side of this portal, you can get a grip on what is the cost of what I've deployed. How much is it going to cost me per hour based on what I've deployed? How much have I accrued month to date? What is my projected month-end cost? So you have a granularity of control over your costs, and you see the green plus sign on the top left? That's where you can add a server and where you can delete a server. So this is where you get that granular hour-by-hour control of your infrastructure. You can do this through our GUI, it's an Ajax GUI, or you can do it through our API. And this is one of our messages to you as developers, is that it's starting to be your responsibility to manage these physical resources. So you need to start thinking, maybe for now, as a stepping stone into cloud computing, you'll use our GUI to deploy some machines, to deploy some apps on. But the next step is for you to start controlling from your software the deployment of those machines and the deletion of those machines. So you scale up during peak loads and you scale down in the middle of the night or whenever you don't need them. So here's an example of you click on the Add button, and in this case, from a drop-down menu, we've selected a Windows 2008 server with 2 gigs of RAM. You can deploy up to 8 gigs of RAM using our API, the operating system, and the image. And this is where you can select from an image. In this case, you're getting IIS, you're getting ASP.NET, and you're getting Microsoft SQL 2005 Express. And a big library of images are available. And let me talk for a second about these images, because this is one of the benefits of cloud computing. I've had people say, well, I just want to buy my hardware. That's cheaper. I've done the math. And, if you add it all up over 3 years, my hardware's, it's going to be cheaper if I just buy it and own it. Well, one of the many things that you're neglecting is the labor that you put into setting these machines up. So how many times do you buy a machine and 35 months later you really are still running the same operating system and you've never rebuilt that machine across that 35-month period? Sure, it happens. You all have them. But I'm sure you'd agree that's the exception typically. So when you're in a cloud environment, if you want to change from Windows 2003 to Windows 2008, it's just a few clicks with the mouse or it's a few calls of an API. When you own your own hardware, I'm sure you'd agree it's many hours of labor. It's frustrating, and if you're really good at it, you'll get it right pretty quickly. But if you're not, I think you'd be much better off with images that have been vetted by lots of other users and professionally put together and well proven to work in the environment. So what do you get in hardware in the cloud? The answer is everything that you get in your own data center. So with Azure, you saw some amazing tools to build some really incredible cloud-based apps. And we all look forward to you doing that. But if you want to get started now with cloud infrastructure, you can do it on GoGrid, and you get real contiguous blocks of static IP addresses. And these are, by the way, things that you don't get on Amazon. You get real VLANs, a segmentation concept that doesn't exist on Amazon in the form in which you guys are probably experienced with it in your own data center. You get persistent local storage. So it's a real machine with a real hard disk attached to it that you can really count on to be there. And if that machine reboots, you'll get that same IP address, you'll get that same VLAN, and you'll get that same actual local hard disk. And that's an experience that you don't get on Amazon. That all gets reshuffled if you have to recreate a machine, if a machine crashes. So y'all are familiar with 2008 and SQL Server. We also have F5 load balancers built in failover pairs, just like many of you might be accustomed to using. And for those of you that, again, don't want to rush everything into the cloud or want to have a hybrid architecture, we offer Cloud Connect to a dedicated back-end system. So again, stepping into the cloud, something that you can't do with Microsoft, you can't do with Azure, but a way to have part of your architecture in an architectural fashion that you all are comfortable with, and the rest of it cutting edge and best practices in the cloud. And I've shown you our screenshots of our Ajax GUI and told you about our API standard, which, by the way, we put into the open source movement, and we're looking at a lot of other cloud providers and cloud service providers adopting our API as a standard, which is something that we're promoting. Is there by chance any other cloud computing vendors in the audience? Okay. Spread the word. We're offering our API publicly for them to use. So I want to move on now about one of the great benefits. This is the sexiest part of cloud computing, and I think it's one that's probably brought a lot of you here and why a lot of you take interest in it. It's actually, I think, ease of use is the killer reason why you guys are going to really enjoy cloud computing in the future. But scalability is what's selling now. So there's two ways to scale. You've got your horizontal scalability and your vertical scalability. So we promote both as best practices, because they both have the yin and the yang that you gotta go through. So let's take horizontal scaling first. The way you scale is by adding more web servers, more application servers. Okay, this is something you can continue to do and do and do and do and do, and if you need to add hundreds, you can do that in the cloud, and you can do it in a fashion that's a lot easier than you can do yourself. So that's horizontal scalability is one of the great options that comes with cloud computing. It's a little bit complex to do, though. So in James Conrad's presentation, if you saw it, he whipped up a web app, and he programmatically had to tell the thing how many servers to spin up, in that case to support his SQL services. So again, you have to take the good with the bad. You have to control the software, and you have to control the infrastructure, but you do get that control. So it's a bit complex. The capital costs are low because you can spin things down as easily as you can spin things up, and you're not buying these servers. You're just spinning them up for when you need them, maybe an hour, and spinning them down when you don't. And the engineering costs are high because you have to do this in your software. You have to take this control programmatically. Vertical is the old school way of doing it. You guys build an app, you give it to the IT department. If it's running slow, maybe they'll open the box up and stick a few more sticks of RAM in it. So it scales by using bigger machines and more powerful machines. Every 18 months you can double your compute capacity. So it's a reasonably sound strategy. It's not very complex. You don't have to do it in the software. It is going to cost you some money, though. And it's going to cost you money in two ways. First off, when your hardware is too small, it's going to cause you pain because it's too small. And then when you expand it, it's going to be bigger than you need, so you've got some waste there. So your capital costs are high, and you got a lot of waste. So that's what's going on here, and this graph is difficult to see, but let me tell you about the dirty little secret about the economics of cloud computing. So we have thousands of customers for our colocation offering, and thousands of customers for our managed hosting offering. So again, the first two steps of this spectrum that Microsoft is talking about. And we know that 95% of the CPU capacity, of the compute capacity of those infrastructure, those installations by those thousands of customers, 95% is wasted. Okay. Now I know every one of you in here is thinking, oh, we use our hardware better than that, and we might get slash-dotted or tech-crunched, and so it's okay that we have all this extra hardware, and you're all justifying it to yourselves. But I know from looking at thousands of real-world data points that on average, you guys are all kidding yourself. You're all wasting because most of you are using your own hardware or managed hosting providers. You're all wasting 95% of that computing capacity. So back to that AMD 18% faster chip, and what does it really do, and 18% less power or whatever, not that big of a deal. You guys are wasting 20-fold. So that's, an order of magnitude of waste. So the dirty little secret of cloud computing is that it's a shared platform. And you guys can all pool that wastage together, and you can all be prepared in case you get slash dotted or tech crunched. But you don't have to pay for it unless you're using it. And when you do use it, you only pay for what you use. So that's, in this type of economy, 20x waste. This is a once in a generation. Okay. And this is a waste across all disciplines of computing. Let's take ease of use. All that time your IT administrators spend building out machines, loading operating systems, closing ports, opening ports, securing them, patching them, making sure it's the right release, and then you guys decide, could you deploy that on Windows 2000? We have a bug on 2003. I'd like you to go back and do that. Look at all the waste of that IT staff. So cloud computing, anybody here an IT administrator, not a developer? Okay, well, I don't mean to be too offensive, but this is what we're talking about, is eliminating that waste also. Because this can all be done programmatically now, either through a GUI or an API. So the whole point is, all of you are buying, when you need a file server, you're buying a whole file server. And when you need a mail server, you're buying a whole mail server. And when you need a web server, you're buying a whole one. And you're buying bigger than you need right now, because you got to be able to handle those peaks and demands. And that's over with. You're going to buy servers that are only well suited to the exact size of the compute needs you have, and there'll be a lot less waste. And so, in terms of this 20x savings, if you want to know, is cloud computing truly less expensive? I mean, come on, John, you're talking about all these other great cost of ownership things. How do the costs really stack up? Well, yeah, there's a lot of savings there. And so we can price the product in a way that just on a short term, without consideration of these other values in terms of easy use and scalability and best practices and whatnot, just in the cost of the hardware and the bandwidth alone, yes, it's less expensive. And we as a provider are pocketing a lot of that improved economics, and we're passing a lot of that improved economics onto you. So the business model behind cloud computing is very, very sound for not only for you, but also for the provider. Anybody have any questions? Yeah. Say the nature of the data again. Highly confidential data.
Highly confidential data, whether it's for official use only, or I guess it would be unlikely that you could do classified type data. But have you ever worked with anything like that before, or?
Absolutely. For example, one of our customers is Kaiser. Okay, Kaiser Permanente Healthcare. I'm sure you can appreciate that health records are, of paramount security concern. So I've got two answers to that question. First off is hybrid architectures. So the question is, security concerns. There's a lot of enterprise that just can't let data outside their walls, or they can't let data outside the country, or they have to have data managed in a PCI compliant way, or some other regulation around their data and other security concerns.
So you're going to say keep the confidential data local and then distribute everything else in the cloud, maybe?
That's a hybrid idea, yes. So you could have a database on-premise at your physical location and have a VPN tunnel, maybe hardware accelerated, maybe even a dedicated telecommunications pipe, not just a tunnel over the internet, so it's even more secure and higher performance. And so you can keep that data on the back end and have web and app servers in the front end. Okay, so there's all kinds of hybrid solutions to these very real security considerations.
Yeah, because I know that would be the first thing we would be asked if we wanted to move this. Someone would raise their hand. And a lot of times it's not classified, it's just for official use only, which is actually a lot of times more annoying because it's vaguely generic. You can't pass it to certain people, and people get touchy. But
right, and so yes, we're committed to hybrid architectures. Now, and those are a real solution to people like you that have government work with those type of government restrictions and other regulatory concerns. However, so there is a solution today, and this hybrid solution will become more and more commonplace. However, I think there will be a mind shift. And the preponderance of data theft is perpetrated by the employees of the company, by the government people themselves. It's always an inside job when you have problems with your data. And so it's our belief that best practices will very quickly evolve to keeping your data in the cloud. So Kaiser, for example, is going to make a shift when they can to putting their data with a certified third-party provider that doesn't have a conflict of interest, that doesn't have an axe to grind, that can help protect them from their own employees, and that is regulated and engages in best practices and has certifications that Kaiser will never be able to maintain. So for example, we're a gold certified Microsoft partner and we have the security competency. So those type of certifications will grow and grow and grow. Kaiser does not have that, that type of internal regulation for their internal clients with their, they have their own policies, but they don't have standards-based regulations. So I think in the future, we get this question every time I make this speech. What about my data? What about security considerations? And then I always say, well, it's like in the old days when you couldn't trust your bank. And then everybody laughs. And then in the old days, back in the 1800s, you put your money in mason jars and buried it in the backyard. And then banks came along, and it took a while before people really started to believe that it was safer to have their money in the Wild West sitting in the bank. That was a big target and blah, blah, blah. But I mean, it did happen. There was that mind shift, and now you entrust your money. And this, yeah, see there. You get a T-shirt. Oh, here, and a hat. All righty. So great question, and thank you for that question, and you get a T-shirt. You asked for first question. Watch out, Dave. Okay. All right, cool.
So what's the smallest companies that you consider moving to this model? There's companies like my sister's that have, a hosting bill of $20 to $50 total a month, to get a shopping cart and everything they need to run their business.
The question is, what about really, really small companies? I guess his sister's got a small business with a $50 a month shared hosting bill from Yahoo Commerce. That's already cloud computing. They're already on a shared platform. So they are, she's already engaging in best practices. What we're talking about here is infrastructure. Engaging in best practices with infrastructure. Owning your own hardware for her. And so I'm going to make her watch this video.
Hello.
She's
Dr.
doing fine.
Gogrid here again
She
with
should not
yet
go
another
out and
computer
buy,
geek. Geeking out on
buy
his
service, 'cause
hardware.
I might blow
Dr.
them out.
Gogrid, you can trust me. What are you geeking out on here?
I'm geeking out on Dell, HP, Cisco, Sun. I've even got an EMC there. I got complete control of my hardware here. I got to make sure it's scalable and reliable and doesn't blow up on me.
I tell you, just because your gear says enterprise doesn't mean it's not going to blow up on you. I've written you a prescription for cloud computing. In fact, call me in 10 days, and you're sorely mistaken. Your equipment's going to blow up on you. That server hugger, and you server huggers with enterprise-grade hardware and software, you need to learn that that stuff will blow up on you.
Okay. Send that to your sister. She's doing fine. So here's some scalability options on GoGrid. You can see some of the stuff is in the cloud and some of the stuff is not in the cloud. And I can see that the text is too small for you. But you can see that you can scale with hardware that you own, and you can scale with cloud storage, and you can scale your web servers using a load balancer. And this can all be connected with a private VLAN in the middle. So in this example, you have a combination of dedicated database servers and cloud database servers that are read-only database slaves. And that helps you with some of the scalability problems. Yeah?
So walk me through your provisioning model. So you have like dedicated racks of servers that you're just dynamically creating VLANs for? Or because I guess one of the tenets around Azure is
whenever that peak demand goes up, provisioning out those instances, and whenever you don't need it anymore, you deprovision. Talk a little bit about how your model works in terms of how you're provisioning out. You're provisioning out physical hardware, and then, or are you have this thing already set, and you're basically slicing and dicing via VLANs and pushing down OS images. I mean, how does that work?
The VLANing is done. The question is, how does this compare with Azure spinning up VMs, independent VMs, and how does that relate to the networking?
Yeah, I mean, what's your overall provisioning? How you provision out?
We're using the Xen hypervisor. So I'm pretty sure that Azure is hypervised with Hyper-V. It's not.
It's custom.
Okay, custom. And I know you have a question too, so I'm going to get that hat ready. We're hypervised on Xen. These are virtual machines. There's a massive pool of nodes, and you can deploy as many virtual machines as you want. So I think does that address how a VM is spun up? It's hypervised?
So basically, I guess my question is more to go Grant, as to how you're provisioning out this environment for scale, these servers where you, and it sounds like you're doing a similar model, but you're using Xen to provision out these server instances, if you will.
Yeah, from a big pool of...
Having, racks of hardware that you're just dynamically setting up VLANs and adding more machines, physical machines to whatever customer demands.
It is true that we have a big pool of hardware. We call each machine a node, and we're constantly adding nodes. But that's not something that's really obvious to you. You just know you can spin up as many VMs as you want, and they're hypervised.
To Azure's computing fabric, where you have this repository of commodity hardware that's shared across the customers that are using it, and you're basically spinning up and deploying these virtualized instances that serve as your application environment.
That's exactly right. And VM number 1 of yours may be on node number 500, and the other one might be on 5,000, and you just see VMs 1, 2, 3. And then to respect to your question about VLANing, we're using standard Cisco hardware, so 6500 switches and 4000 series switches. And we'll just run you a physical or virtual cross-connect, either right through the switch, or if cabling is necessary to your colo cabinet, we do that. Did I answer your question?
Yes.
And you had a question in the back.
The biggest difference between using a software like, I guess, Virtual Iron instead of using your hardware or something? Or?
Virtual Iron would be great for a private cloud. The question is, how would we relate to Virtual Iron or VMware? And the answer is that those are great solutions for hosted or private clouds. So if you're an IT department and you have a bunch of internal customers and you want to offer up VMs to your internal customers, you could do that with VMware or Virtual Iron. Yeah.
What kind of guarantees do you guys have on processing power per virtual machine?
We have guarantees associated with the availability, or do you mean the amount of that power?
Yeah. Like, say I had a large data set I wanted to run some analytics on, and I wanted to know how many CPU cycles I'd get, per hour towards that.
Sure. Well, we have several different machine sizes available, and I have a slide a little bit later on that shows this. But you get more CPUs assigned to you, the more RAM that you deploy. And so by deploying more and more CPUs, you get more and more, deploying more and more RAM, you get more and more CPUs automatically. And so that's the answer of how you...
And are those CPUs dedicated to you, or are they still, on the node, and there might be 4 other virtual machines running as well, and who wins, who gets context switched out, things like that?
Sure. They are a shared environment. So in a worst case scenario, everybody will hit all the CPUs all at the same time. In a practical scenario, it doesn't happen that way. And so especially when you're using horizontal scaling and you have multiple units, you will never see a contention issue. Practically speaking, it's just not an issue. It's a theoretical concern. And I'd encourage you to experiment. It's not a practical concern. So the cloud benefits. We've talked about how it's scalable, how it's on demand. Especially in the case of GoGrid, you can get started with this easier. If you've got an app you want to deploy, you can do it yourself. You don't have to get your IT department involved. You can spin up your own machine yourself in the middle of the night. It reduces costs, and I want to remind you that it's not just lower costs because at face value, it appears to give you more computing per hour for less money. It's that you only pay for what you need. And all of you on average are buying 20 times more than you need. And so it's also easier to use. You don't have to have IT staff that builds machines for you and changes machines and scales machines for you. So, there's no commitment. So if you use this $200 card and you spin up a bunch of stuff, and then you decide you don't like it, it's not for you, just shut it off. If you want to see if your application can run on Windows 2008, you can do that in a few minutes. And if it's not something you want to do right now, you just shut that machine down. You've probably wasted as little as 8 cents. So there's no risk. And I think all these things combined will give you a competitive advantage. So that's pretty much my wrap-up. And I'm going to take a few more questions. And before I do, I just want to emphasize we'd really like it if you could distribute these $200 cards to your IT staff and give them some familiarity with cloud computing. I'm curious how many people would guess that somewhere at your organization you have people with a mandate to gain familiarity with cloud computing. Give it a try to investigate it. Okay, so here's a way in 5 minutes they could deploy a few cloud servers with a mouse and say, hey, we tried it. And for those of you that have to do some scalability testing, anybody here have a mandate to do scalability testing? Okay, here's a way you could try that. See if your app will run on 20 machines. See if it'll run on 100 machines. And that could cost you just a few dollars. Yeah. Yeah. So give it a try. Yeah.
Can you speak to that scenario? You talked about having images with various OSs. If you had a case where you want to deploy that across 20 servers, are you able to make an image of one server and say spin up 20 of these? Or how does that process?
That's something we call private GoGrid server images, where, and this is a feature that we have in development right now, and it's not something that you'll see in the public portal right now. But image management is one of the key benefits of cloud computing for exactly the reason you said. You can set up a server in a sandbox environment, install your application on it, secure it, do all the other things you need to do to solidify it and optimize it, and then put that in your private repository, in your own private library. And then every time you need another one of those servers deployed, just the way you configured it, you just click the Add button, and then there'll be a drop-down menu where it shows your list of private GoGrid server images. And so that's how you can quickly and rapidly scale. It's how you can quickly and rapidly test. Because if you set up, if you're using this, GoGrid is awesome for test environments, because you can set up these servers, test on them, blow them up, and then roll back super, super, super easy in a way that's never before been possible. Thank you. That's a good, great question. Yeah.
With regard to scaling storage, I heard you say that there's a lot of compelling arguments to actually store data in the cloud as well, and there's a certain cost for doing that. There's, and for instance, for my company, we host a lot of public records. It's a government thing, and we're actually statutorily supposed to be doing this. And right now,
doing what?
I'm sorry.
Statutorily doing.
We host public records for the state of Georgia. So.
And you've got to keep the records.
Real estate documents, liens, whatever. We image them and we keep a repository of that. So right now we have about 35 terabytes of images. I imagine Kaiser has a pretty huge stash of documents as well. But in that case, you're using the storage. It's not going to change a lot. So your storage needs are always going to be well, or is that not a good fit?
So this would be akin to S3 or blob storage or our GoGrid cloud storage. The question is, the gentleman's got 35 terabytes of secure records. And so I guess you're asking two questions. One is about the security.
Well, not so much, because I think he answered that already. But,
Okay.
As far as the scalability of cost, that's a lot of storage.
Now, is it 35 terabytes every day, or was it 32?
But it's aggregated over time, so
And
gonna
it's
continue to
growing
grow.
very slightly.
Correct.
So, I know what's going to happen. Some super geek at your organization is going to want to buy the next 100 terabyte EMC SAN, and he's going to have his heart set on operating this really cool box. He's going to really try to build up a cost argument. But the bottom line is you just have to do the math. In month 1, I'm using 35 terabytes. In month 2, it's 37. In month 3, and when you look at it that way, and then when you factor in what if you don't get to 100 terabytes when you think you will? What if you get to 100 terabytes faster? Okay. What if you get to 100 terabytes slower? And you have to factor that into your economic analysis. And so this super geek, he's going to have proven it's 25% less expensive, because when we get to 100 gigabytes on March 13th of 2011, I can prove to you the total cost of ownership is lower. But do you really know what you're going to have on, stuff changes.
The other argument Super Geek would make, of course, is that he would, with that much data and a responsibility to keep it, I think, cloud computing is kind of abstract for some people to get their head around about how, if there were a data issue, how it could be restored, or what level of protections there are there.
Yeah, Super Geek would have a hard time convincing somebody that was really informed that his fancy EMC system really could be as reliable and as permanent as cloud storage can be.
Super Geek has tape backups like that.
Yeah, I understand.
I mean, but these are questions I know I'm going to.
That would be a big battle. You're right.
But you do think there's a fit, is what you're saying?
I think it's absolutely the way it'll be done in the future. But that's kind of my job to feel that way. I made those stupid videos, so. Yeah. Well, in the case of, the question is about LUNs and SLA and throughput. And that's, as I understand it, more of a SAN type of attached storage paradigm. Understood. So in the case of this gentleman, I was talking about blob storage or file storage, S3-like storage, where the I/O is not, you're not mounting this storage, and the I/O considerations are not the same. In the case of GoGrid, you're using direct attached storage, and it is dedicated hard drive space dedicated to you. You, in some cases, may be sharing a spindle, but yes, you will see it just like it's a standard machine that you own. Okay, in terms of the mounting the storage and the I/O. That's one slight difference between GoGrid and Amazon, is that in the GoGrid environment, we have dubbed that storage persistent, meaning you can architecturally rely on it to be there, and if you've mounted those LUNs and whatnot, it's there. In Amazon, if the node crashes for any reason, that storage is gone, and any file systems you've set up have to be rebuilt. And so in that case, you use their blob storage or their elastic block storage to keep your data backed up or mounted elsewhere. So a hybrid architecture, yes. SQL databases are extremely hard to put in the cloud. They're extremely hard to scale. You guys all know that as developers. And that's why a hybrid architecture is probably the right call for that type of high capacity database. That's the solution everybody's working on. You know, Microsoft has their tables, I think they're calling it now. You know, and then you've got Big Table and Simple DB as being other ways to try to get around the SQL scalability problem.
You also have SQL data services, which just recently announced full relational capability in that. So think of it as SQL Server hosted in the cloud and massively scalable.
Absolutely. It's definitely right. Yeah?
Where are your nodes geographically dispersed?
Geographically, they're all in Silicon Valley right now, although we have some new announcements coming. And we do content delivery from global places, but your data would reside right now in Silicon Valley. It would just be distributed from, for example, we have Windows media servers in other places on the globe where we can deliver media files for you, you know, to handle latency issues and whatnot.
Any in Australia?
You know, we don't have a physical point of presence in Australia, but I can tell you that a number of Australian streaming companies are using our network to stream video and audio to Australia, and we can give you some testimonials there. Any other questions? All right, cool. I got a bunch of hats left. Oh, yeah, one more question.
How people sign up for BizBark through you or through ServiceNow?
David, you want to handle that one? Questions about signing up for BizBark, which we're a big part of.
Yeah, I think ServiceNow.com/BizBark or I think GoGrid.com/BizBark. And we definitely get you set up. The Windows licensing in GoGrid is included. There's no extra charge, but if you have SQL Server standard on some of the images, so we could eliminate that cost for you if you sign up as a BizBark startup.
Questions, BizBark, I'm supposed to repeat the questions. Questions, BizBark, sign up. It's at gogrid.com/BizBark. And so please do that. They're investing a lot in really promoting that. Hey, there's some survey forms that I'm supposed to remind you to please fill out, and I believe you can give them to the lady in the back. Okay. Thank you very much.